So this section actually is still related to polynomials, but it's called Pascal's triangle. I mean, some of you may have heard of this already, but I'm going to go through what it's all about. It's actually quite useful, and I posted a video in line just a few minutes ago, and there's a discussion about Pascal's triangle, and it's actually used for many things, not just for what we're going to do today. So you can take a look there. Now, Pascal's triangle comes from a French mathematician, Blaise Pascal, okay? And he lived a long time ago. This is 1623 to 1662. So you can see he wasn't very old when he died. Back in those days, people didn't live very long. So unfortunately for him, he didn't live for a very long time, but he did quite a lot of things. So let's look at some number patterns. It's really about number patterns. Number patterns. And we use this Pascal's triangle to get the coefficients of polynomials. So let's see how we do that. I'm just going to scroll up now. So if you want to copy that, you can. So let's look at some number patterns. Let's start out with just 1. Okay, 1. So you can copy this down, or you can take a look in your book to see how this is working. But what I'm going to do, I'm going to write zeros next to that in red, just for the start. Okay, so we've got 1. And then what we're going to do is call that row 0. This is row 0. And the next one will be row 1, row 2, and so on. I'll write them down more in a minute. So if we add these two numbers, so 0 plus 1 is 1, and 1 plus 0 is 1. So we've got 1, then 1, 1. And then if I write 0 again on the end, and I add again, oh, I should put 0 here, sorry. So let's put 0 there. And then we add those pairs. I'm going to have 0, 1, which is 1. 1 plus 1 is 2. And 1 plus 0 is 1. Okay, and then I can add a 0 onto here and do that again. So this will be row 3. So let's add those like this here. So the 0 is actually not required once you get used to this pattern. So then we're going to have 0 plus 1. That's 1. 2 plus 1, 3. 2 plus 1, 3. 1 plus 0, 1. Like that. So this is row 3. And I can put a 0 on there for the next adding that we do. So the next row will be row 4. Like that. So I'm going to scroll up. So if you're copying this, you can copy it down fairly quickly. So then I'm going to add these for row 4. 0 plus 1, 1. 3 plus 1, 4. 3 plus 3, 6. 3 plus 1, 4. And 0 plus 1 is 1, like that. And let's do one more row because the pattern is the same. Row 5, add on a 0, and let's add again. So 0 plus 1, that's 1. 4 plus 1, 5. 6 plus 4, 10. 6 plus 4, 10. 4 plus 1, 5. And 1 plus 0 is 1. So you can keep going if you want, but what I'll do, I'll just rub out the zeros because they're not really part of our final answer like that. Let's just clear those out. So let's see what's happening here. So we got 1, we've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and so on. So you can see this forms a triangle, doesn't it? And it can go on to infinity. So the numbers will add up like that. So one thing before we go on, if you consider powers of 11, so this is one use of the Pascal's triangle. 11 power 0 is 1, isn't it? Yeah. 11 power 1 is 11. 11 here. 11 power 2 is, you guessed it, 121. 11 power 3 is 1331, and so on. So you can do powers of 11 using this tree, okay, using this triangle. And 11 power 4, 14641, and so on. You can check that with your calculator, and that works for every row. So powers of 11 actually are the rows of the triangle. So that's one use of Pascal's triangle. You'll see that. Another one, we'll do some more later, but you can watch that video that I sent you. They have actually quite a lot of uses of this triangle. Okay, but what we're interested in is about your polynomials. So let's write that there. It's an A. Okay, so for the first one, this is row 0, right? So what I'm going to do, just make up X. Well, let's make it A and B. A and B would be better because that's what we used in the book. A plus B power 0. That 0 is this 0 here. And A plus B power 0 is 1. So that's equal to this number here, right? So you could then have A plus B power 1, which is A plus B, isn't it? A plus B. Now the coefficients here are actually 1 and 1, which are these numbers in yellow here. Okay, A plus B, and these are the coefficients. And then remember when we did A plus B power 2, whoop, put the 2 on the outside, like that. So if you expand that, remember we got A squared plus 2AB plus B squared, didn't we? Like that. And our coefficients here, we have a 1 here, and we also have a 1 there. Notice that these are the same as these three numbers. 1, 2, 1. Okay, 1, 2, 1. So these are turning out to be the coefficients of the polynomials. So scroll across there. So for the third one, remember A plus B cubed. If you expand that, remember what we got? We got A cubed plus 3A squared B plus 3AB squared plus B cubed. Remember that? That was from perfect cubes. And of course, we have polynomials. We have coefficient 1 and 1 here. And you can see the coefficients 1, 3, 3, 1. So 1, 3, 3, 1, like that. So that means the other polynomials which you haven't learned yet can be done the same way. So you can copy this down if you want. So we'll do a couple and then we'll do some examples. A plus B power 4. So we can use these numbers as the coefficients now. So a plus b power 4, well, we start off with a4, don't we? a4, and the power there is, well, the coefficient there is 1. And then we've got 4. So then we go 4, remember what happens to a4? a4 becomes now a3. That power decreases by 1, but then we introduce the b from the last term there, b power 1. And then the next coefficient is 6, so we'll put 6 in. a3 becomes a2, but then b1 becomes b2. That would increase by 1 power. And then we've got 4. a2 becomes a1, b2 becomes b3. Okay, and the last coefficient is 1. I'll put that in red because that would be rubbed off anyway. Plus 1. And then you have b4 for the last term there. So for the 1 coefficient, we don't normally write that. So pretty much that could be rubbed out. I'll put out that last one without erasing everything. So a4 plus 4a3 b1, and so on. So plus b4. Just notice what's happening to your coefficients. We've got 1, 4, 6, 4, 1. And don't write the 1. And then how about, what if you were doing 5? This would be done exactly the same way. So this one would be a plus b5. That's row 5. So you start off with a5. Then your coefficient here is 5. So 5a4, b1. And remember, these two powers should add up to 5 every time. 4 plus 1 is 5. This is 5. Okay, so make sure they add up to 5, each pairing. So 5, and then your next two coefficients are 10 each. So plus 10, a3, b2, plus 10, a2, b3, plus 5, a, b4, plus the last one is 1, and that would be b5, like that. So this is the pattern for when you have power 5, and your coefficients are 1, 5, 10, 10, 5, 1. So if you can remember how to make this triangle, you'll remember how to write the pattern out, okay? And you can do that for more and more rows, if you like. Now, if it's negative, now just to tell you now before we go on, if it was negative, a minus b5, for example, any of these are negative, then your sign is going to change. So if you're doing, I should write that in red just to make it clear. So if it was a minus b5, then the signs will alternate. The first one is plus, but then it will become negative, plus, negative, plus, negative, like that. And the same for this one. If it's negative here, so you have plus, negative, plus, negative, plus, like that. They alternate. Plus to negative to plus to negative, so on. Again, if this is negative, plus, negative, plus, negative, like that. And for your perfect square, if it's negative, plus, negative, plus, as we learned these two already, didn't we? Okay. So as an example, before you do any in the book, because the book is just factorizing, but once you can expand, you can factorize. So if you have a question, you can write this in your book, 2x plus 1 power 4. Okay, we'll do a couple here. I'll do one down here in a minute. So when you want to expand, This is what we're going to do. We're going to expand this fully. Okay, so if you've got 4, think about your row. Let's go back up to row 4. Okay, this one here. So we're looking at this one. So these are the coefficients, 1, 4, 6, 4, 1. So what you can do is write those coefficients down here as 1, 4, 6, 4, 1. We know these will be the coefficients when we have power 4. So I'll give you a few minutes to think about how to do this, and then we'll do a negative one. So let's do one that's, I'll write it down here. So if you think you know what to do, have a go. I want you to write it out in this form over here on the right side, the right-hand side over here. But put your coefficients in and do your expansion, and then I'll come back in 5 minutes and then see how you went. So do this one, 3c plus, let's keep it as plus 2x cubed. So let's expand these. And this is cubed, so it'd be 1, 3, 3, 1 for the coefficients. 1, 3, 3, 1. I'm leaving some space for you to write here. Okay, so let's take a look at these 2 questions. Hopefully you finished already. Okay, so start off with your first term, which is 2x. And that will start off as power 4, okay? 2x power 4. And we have plus, so all of the signs will be plus. That 1 here, your coefficient 1 goes there. I just didn't write it. So then we've got 4, the coefficient will be 4, 2x cubed, and then 1 power 1, which you don't really need to write, do you? Plus 6, now 2x cubed will become 2x squared, and 1 will become 1 squared. Again, you don't really need to write that because that will cancel out. Plus 4, 2x squared will become 2x power 1, and 1 squared will be 1 cubed, and the last term is 1 power 4. So you can see your coefficients are here, 1, 1. I put 4 in here. I put 6 in here. 4 is here, and your 1 is in there, which I didn't write. I could put it in, but you don't need to. So you've not actually finished when you've done that. You can see you can still simplify this, can't you? So 2x power 4 will be 16x4. And this is 2 cubed, 8. 4 8s are 32. X cubed. And this is going to be 2 squared, which is 4. 4 6s are 24. 24x squared. And then you've got 2 to power 1 and times 4, so that's going to be 8x. And your last number, 1 to power 4, is 1. So you should hopefully have gotten this answer here from that expansion there. Okay, which is equal to this in factored form. In your textbook, we don't do this. In the textbook, they just want you to go backwards to this here. So what you really need to do in the textbook when we come to it is go backwards from this to this and then back to this here. So we just go this in reverse. Okay, so that's that question. Now this one is power 3. So 3c, and we've got a cube. So we're going to have 1 3c cubed first. The 1 is the coefficient I put here, which you don't really need to do because it's 1. And then we'll go to 3, the coefficient 3. 3c cubed will become 3c squared. And then we've got 2x. which you need to introduce here is 2x power 1. Okay, and then we'll move that across. So then we're going to have coefficient 3 again. 3c squared becomes 3c power 1. 2x1 becomes 2x squared. And then the last term cubed, 2x cubed. So I could put the 1 as the coefficient there. So the coefficients are 1, 1, 3, 3, 3, 3, then 1, 1 here. So the coefficients just go into your question in here. That one, and that goes in over there. Okay, so then you should simplify it. So that's going to be 27c cubed. Then we're going to have 54 c squared x. Then we're going to have 36. 2 2s are 4. 4 3s are 12. 3 12s are 36 c x squared. Okay, from this one here. And 2 cubed, that would be 8x cubed. Like that. So that should be your final answer for that one there. Did you get that okay? Hopefully. So hopefully you're following this, okay? But you can also go back and review this video when I'm finished, when you do the worksheet. Not much on the worksheet. And remember, your worksheet's due on Friday, but I don't think I actually included power 4, okay, questions, but just for your information. So if you did another one, I don't really want to spend too much time on this, but we've got, let's do this one. You try this first. 3x minus 4y, and let's just keep it as cube, okay? So you can do that because you've done this one before. And your coefficients, that's the first thing to think about. With the cube, remember, let's go back to cube, that's row 3, 1, 3, 3, 1. That's this one here. So 1, 3, 3, 1. So write your coefficients first. 1, 3, 3, 1, and leave some space. Okay, so you do that for a few minutes, and then we'll do a little bit in the book, because the textbook is only like 3 questions anyway. Okay, so do that for 5 minutes, or 3, say 2 or 3 minutes, and I'll come back. Okay, so for this question, let's start off with the first term, 3x cubed. Okay, so you've got 1 for your coefficient. I'll put it in red. So 1. Then you've got 3x cubed. So remember to alternate the sign. This is minus. So the first sign is minus. Here, the first one is plus, but the second one becomes minus. Then you've got 3 for the coefficient. And then 3x squared. Then we introduce 4y power 1. That minus now becomes plus 3, the coefficient. Then 3x power 1. Then 4y1 becomes 4y squared. And then, so negative plus negative, coefficient 1. Then 4y cubed at the end. Like that. Okay, so those are your coefficients. 1, 3, 3, 1. And plus, minus for the pattern of the signs. So just get used to that. Start off with plus and then alternate. Okay, so 3x cubed, we're going to get 27 x cubed. When you simplify this one, you're going to get minus 108 x squared y. So 3 squared times 4 times 3 plus 144 x y squared. Let's put the x first. xy squared. Then minus 64y cubed. So you should get this for your answer there, okay? So you can copy that if you like. So that's just expanding. It's a quick way to expand. Otherwise, you need to do this the long way and you end up making errors. You can make errors when you do it the long way. So this is chapter 6. So I've explained this already, and you can see power 5. These are your coefficients, 1, 5, 10, 10, 5, 1, and so forth. Okay, so this shows you the pattern. They call it the binomial expansion because bi being two parts. And then just showing you the diagram of the triangle there. And that's how to add them. I explained that already. There's a couple of examples here, but we don't have a lot of time. So just go down to the question. Okay, there's only 3 questions here and we only have 10 minutes. So you can do these fairly quickly. So take a look at your problem. You've got an x cubed. So I look at the first term and I look at the last term, 125. So x cubed is x cubed, isn't it? We're done with that. But 125 is 5 cubed there. So I suspect my answer, which I don't know yet, could be x, and notice all the signs are plus. Okay, so x plus 5 cubed, so that would be 5 all cubed. So I'm thinking this is probably the answer already. All right, but I don't actually know because I haven't checked these middle terms. I need to know if these are correct, because if this was 10x squared, this is wrong. We can't do it. We need to have these 2 numbers in the middle here being correct. And I've explained that before in other lessons. So we do our expansion using the formula. So from formula, now this is a cube, it's looking to be a cube. So we'll do the cube, which is the coefficients are 1, 3, 3, 1. Those are the coefficients. And then I just build up and see if I can get this equation. So we've got x and 5 as a and b from the formula from previously. So I'm going to have x cubed plus 3x squared, and b is 5, plus 3x 5 squared, just from the formula, plus 1, 5 squared will be 5 cubed. So I need to check that this is the same as this. And if it is, then I can write this as the answer. So just check that, x cubed plus 15 x squared, that's good, same. And this one is 25 times 3, which is 75 x, which is the same, good. And the last term should be correct because we already wrote that out. That's 125. So these are the same. You can see this one and this are the same. Therefore, this will equal x plus 5 cubed because it's following the exact formula as it's written out. So that's your answer there. You can guess the answer already, but we need to do a check. So what this is checking. Okay, we only have 9 minutes. So do this one the same way. I'll leave that there. We also have a cube now. So what you should be thinking is about the first term and the last term. And look at the sign, negative plus negative. So it looks like it's going to be, well, let's write this first. X cubed is x cubed. 27 is 3 cubed, isn't it? So you should be thinking the factors are going to be x minus 3 all cubed. So this is what you should be guessing. So this is your guess. So your answer should be this. But now we check. Can you check this is correct yourself? So, and remember your coefficients are 1, 3, 3, 1. 1, 3, 3, 1. You can start here. So your first term is x cubed. Let's write that there. Then minus. All right, I'll let you a few minutes to try and do that one yourself. Just do it the way I did it here, this one here. I'll be back in 3 minutes and we'll finish that one. If you've done that one, you can do question 3 because there's only 3 questions. Okay, so for this question, we've got x cubed as your first term. Your coefficient is 3 for the next one. And then x cubed will become x squared. And then we introduce 3 from the last term. There. Negative, this will become plus 3. X squared becomes x. And the 3 becomes 3 squared. And then negative plus negative, 3 squared becomes 3 cubed as the last term. I'm just doing this in my head using the formula. So this is formula. I'm not looking at the actual question up here. So this is from the formula. So we've got x cubed minus 3, 3's a 9, x squared, plus 3, 3's a 9 times 3, 27, x minus 27. Then we go and check that these are actually the same, and they need to be the same. So need to be the same. Are they? So minus 9, okay, x cubed, okay. 27x, okay. Minus 27, okay. So if this is all okay, then we know that this will be the answer. So you could say, therefore, x minus 3 cubed is are your factors, okay? So that would be your answer then here. So it takes a little bit of checking, but it's worth to do. There's only a couple of minutes left, so hopefully you can do this one. Just try this one yourself. If you're wondering what the answer may be, so the answer, take a look at your first term and last term. And now this looks like power 4. Okay, so I'm thinking this is going to be 2x power 4 here for this one. And 625 is 5 power 4. So possibly your answer is 2x minus, because we have minus plus minus plus, minus 5 all power 4. So this could be your answer, but now you can check that one yourself and just check that it all works out. But your coefficients now would be 1, 4, 6, 4, 1. Because we're using the 4th power. So 1, 4, 6, 4, 1. So I'll let you do this one yourself and just check these terms are all correct here. You need to check these here. So, but for your guessing, we have 2x. So I write it here. And 5 is here. I write it here. And power 4. So I suspect that power 4 will be the power that we're using here. So I'll let you check that yourself.